What if I told you the next disaster can be prevented before it even begins? Imagine a world where storms cause no deaths, where cities survive earthquakes and nature protects us. This future is real. Your home, your family, your community, everything can be protected with the right knowledge. Every disaster has a lesson. Today we reveal how to use those lessons to build a safer world. Watch till the end to learn more how to protect ourselves, our communities, and our families.
Earth, a planet filled with life, oceans, forests, and breathtaking landscapes. But underneath all of that beauty is something else, something powerful, something unpredictable. Every year, natural disasters reshape the surface of our world. Earthquakes tear apart cities, tsunamis swallow entire coastlines, hurricanes flatten entire regions, volcanoes erupt with explosive force, wildfires rage across continents. And despite all our technology, all our science, we are still at the mercy of a planet that is constantly moving, shifting, and evolving. In this documentary, we're going to explore how these disasters happen, why they're becoming more intense, and what science is doing to help us survive them. But before we dive in, let's start with the question: why does Earth even have natural disasters in the first place? Well, to answer that, we need to go all the way beneath your feet to the moving, living engine inside the Earth. Because our planet isn't solid, it's more like a boiling pot of molten rock, constantly shifting and releasing energy. And every once in a while, that energy escapes violently. This is the story of when Earth strikes back, and how humans are learning to fight back too.
Let's start with earthquakes, arguably the most sudden and terrifying of all natural disasters. 1 second, everything is normal. The next second, the ground is shaking like it's alive. To understand earthquakes, imagine this. The Earth's crust is not one solid piece. It's actually broken into massive puzzle pieces called tectonic plates. These plates float on top of molten rock, very slowly moving, about as fast as your fingernails grow. Sometimes these plates get stuck, but they don't stop pushing. They keep building pressure and building pressure until suddenly, snap! That release of energy is an earthquake.
A real example, the 2011 Japan earthquake. On March 11, 2011, Japan experienced one of the strongest earthquakes ever recorded, a magnitude 9.1. To put that into perspective, magnitude 7 is strong, magnitude 8 is rare, magnitude 9 is catastrophic. When the tectonic plates beneath the ocean snapped, the ground shifted up to 50 meters in some places in just a few seconds. That's like an entire city suddenly jumping sideways. Buildings shook violently, roads cracked open, and the shaking lasted 6 minutes. But the worst part? This earthquake didn't come alone. It triggered something far more deadly, a tsunami. But we'll get to that in the next chapter. Can we predict earthquakes? Short answer, no. We can't predict the exact time, location, or magnitude, not yet. But scientists can identify high-risk zones, known as fault lines, places where tectonic plates meet. Some of the biggest fault lines in the world include the Pacific Ring of Fire, the San Andreas Fault in California, the Himalayan Fault near Nepal, and the Alpine Fault in New Zealand. These areas will definitely experience earthquakes. We just don't know when. How we survive earthquakes today. Modern engineering has changed everything. Buildings now use flexible foundations, shock absorbers, and steel frames designed to sway without collapsing. Japan is the global leader in earthquake-resistant design. Their skyscrapers can bend several meters and still stay standing. They even have warning systems that detect the first waves of an earthquake, giving people a few seconds to hide. And believe it or not, those few seconds save thousands of lives. Earthquakes are deadly because they give no warning, but technology is getting closer to changing that. And sometimes, what comes after the earthquake is even worse.
A tsunami is not just a big wave. It's the ocean in motion. And it often starts with an earthquake deep under the sea. When the seabed suddenly moves, it pushes an enormous amount of water upward. That water spreads out in all directions, traveling at airplane speeds up to 800 kilometers per hour across the ocean. But here's the surprising part. In deep water, you might not even notice a tsunami passing beneath your boat. It can be just a small wave. The danger comes when the wave reaches shallow water near the coast. The bottom of the wave slows down, but the top keeps going. And suddenly, the wave grows taller, sometimes 10, 20, even 30 meters high, a moving wall of ocean. The 2004 Indian Ocean Tsunami. This disaster is one of the deadliest in modern history. It started with a magnitude 9.1 earthquake off the coast of Sumatra. The tsunami spread across the Indian Ocean, striking Indonesia, Sri Lanka, Thailand, India, even Africa. Over 230,000 people lost their lives. Entire coastlines were wiped out. People had no warning, no idea what was coming. Since then, global tsunami warming systems have improved dramatically. Today, sensors across the ocean measure water pressure, earthquakes, and wave speed. If something unusual happens, alerts go out instantly. But here's the truth. If the earthquake happens close to land, you may only have 10 to 20 minutes to escape, and sometimes even less.
Hurricanes are the largest storms on Earth. Giant spirals of wind, rain, and clouds stretching hundreds of kilometers. They go by different names depending on where they form. Hurricane, Atlantic, typhoon, Pacific, cyclone, Indian Ocean, but they're all the same thing. A hurricane begins with warm ocean water. Very warm water. When seawater evaporates, it rises into the air as warm, humid vapor. That rising air creates a low-pressure system. Then wind rushes in to fill it. But because of Earth's rotation, the air doesn't go straight in. It spirals. This spinning vortex grows stronger and stronger until it forms the classic shape we recognize, a swirling storm with a perfectly calm center known as the eye. Inside the eye wall, winds can reach 300 kilometers per hour or more, strong enough to tear off roofs, uproot trees, and send cars flying. Storm surge, the silent killer. The most dangerous part of a hurricane is not the wind, it's the storm surge, when the hurricane pushes ocean water onto land. A storm surge can raise sea level by several meters, flooding entire cities.
In Hurricane Katrina, 2005, storm surges reached 8 meters in some places, enough to submerge entire neighborhoods. Super Typhoon Haiyan, Yolanda, one of the strongest storms ever recorded, struck the Philippines in 2013. Wind speeds reached 315 kilometers an hour. The storm surge was so high, people described it as a tsunami. Thousands lost their lives. It was a reminder that nature's most powerful storms can strike with almost unstoppable force. Is climate change making hurricanes worse? Yes, but not in the way most people think. We're not seeing more hurricanes, we're seeing stronger ones. Why? Because hurricanes feed on warm water, and the oceans are getting warmer. This means storms intensify faster, drop more rain, and last longer. In other words, the hurricanes of the future will not look like the hurricanes of the past.
Volcanoes are time capsules of Earth's inner power. They are literal holes in the crust where molten rock, ash, and gas can escape. To understand volcanoes, imagine a bottle of soda. Shake it and pressure builds up. Open it suddenly and it explodes. Volcanoes work the same way. Deep underground, magma rises, pressure builds, and eventually the Earth's crust cracks open. Sometimes this release is gentle. Lava flows, slowly moving rivers of fire. But other times, it is catastrophic. Mount Vesuvius, the eruption that froze time. In the year 79 AD, the Roman city of Pompeii was destroyed in a single day. A gigantic cloud of volcanic ash shot 30 kilometers into the sky. The ash fell back to Earth so quickly it buried the entire city, perfectly preserving it. People were frozen in their last moments, asleep, running, hiding. Volcanoes don't just destroy, they record history. Mount Pinatubo, the eruption that changed the climate. In 1991, the Philippines witnessed one of the largest eruptions of the 20th century. Mount Pinatubo sent 20 million tons of sulfur dioxide into the atmosphere. This formed a massive cloud around the planet that reflected sunlight, cooling Earth's temperature by 0.5 degrees Celsius for more than a year. One eruption changed the climate of the entire planet. That's how powerful volcanoes can be. The supervolcano threat. There are volcanoes that erupt every few hundred years. And then there are supervolcanoes, monster volcanoes that erupt every 50,000 to 100,000 years. Yellowstone is one of them. If it erupted today, the ash cloud could cover most of the United States. Is it likely to erupt soon? No. But the fact that it can erupt shows how small we really are compared to the forces beneath our feet.
Wildfires are unique. Unlike hurricanes or earthquakes, they can be caused by nature or by humans. Every year, millions of hectares of land burn. Forests, grasslands, mountains. Some fires are natural, sparked by lightning during dry seasons. But many are caused by human activities, burning trash, cigarettes, sparks from machines. Wildfires need three things: fuel, heat, and oxygen. This is called the fire triangle. And when these three elements meet in the right conditions, drought, heat, and wind,
a small spark can become an unstoppable inferno. Australia's 2019-2020 mega fires. These fires burned for months, releasing smoke that traveled around the world. Over 3 billion animals were impacted, many killed, many losing their habitats. It was a disaster of unimaginable scale. The science of fire spread. Wind pushes flames across forests like a blowtorch. Dry leaves act like gasoline. Slopes make fire move faster uphill. A fire can travel faster than a car. It can jump rivers. It can create its own weather, including fire tornadoes. Firefighters today use drones, satellites, and infrared cameras to track the spread. But some fires grow so large, the only thing that stops them is heavy rain.
When most people think of natural disasters, they imagine earthquakes or storms. But sometimes, the most destructive events happen quietly, deep within the mountains. A landslide occurs when rock, soil, and debris suddenly break free and rush down a slope at terrifying speeds. Some landslides move slowly. Others move faster than cars on a highway. What makes them so deadly is their weight. A landslide can move millions of tons of earth in seconds. Some of the worst landslides in history were triggered by rain, earthquakes, volcanic eruptions, or even human deforestation. In 2014, the Oso landslide in Washington state swallowed an entire neighborhood. In Nepal, heavy rains often trigger massive mountain collapses. In the Philippines, the Guinsaogan tragedy buried villages under meters of soil. Scientists use drones and ground sensors to detect unstable slopes. But predicting the exact moment a mountain will collapse? Still impossible. Landslides remind us that even the strongest ground can fail when nature decides to move. Heat waves, the invisible killer. Heat waves don't look dramatic. There's no shaking ground, no towering wave, no roaring wind. But heat waves are one of the deadliest natural disasters on Earth. They kill silently through dehydration, heat stroke, and increased strain on the heart and lungs. Cities become ovens as concrete absorbs and radiates heat. In 2003, Europe experienced a heat wave so intense it killed over 70,000 people, more than any hurricane or volcano in modern history. Today, heat waves are becoming longer, hotter, and more common. Climate change plays a major role. Many countries now use warning systems, cooling shelters, and urban green spaces to fight extreme heat. But for many regions, the worst heat is still ahead. Drought, when the world runs dry. Drought doesn't destroy buildings or trigger explosions, but its impact is enormous. A drought is a long period with little to no rainfall. Rivers dry up, crops die, animals starve, and entire regions face food and water shortages. The Dust Bowl of the 1930s turned huge parts of the United States into deserts, forcing families to flee their farms. Today, parts of Africa, the Middle East, and Australia still face severe drought seasons, affecting millions of people. Drought is slow, but its damage lasts for years. Scientists study weather patterns, soil moisture, and ocean temperatures to predict droughts. But preventing them?
In 2022, Pakistan experienced historic floods that submerged 1/3 of the entire country. Millions were displaced. Floods destroy homes, ruin crops, spread disease, and contaminate drinking water. But technology is improving. Dams, levees, satellite rainfall tracking, and early warning apps are saving more lives than ever. Still, water remains one of the planet's most unpredictable threats. Snow seems harmless, but in extreme amounts, it becomes deadly. Blizzards combine heavy snow, freezing temperatures, and violent winds that make visibility drop to zero. Entire cities can shut down. In 1972, blizzards in Iran buried villages under 8 meters of snow. In 2014, parts of Japan and the US experienced snowfall so heavy roofs collapsed under the weight. Snowstorms disrupt power, transportation, and food supplies. Cold kills silently through hypothermia and frostbite. Today, meteorologists use satellites and supercomputers to predict these winter monsters. But when they strike, survival still depends on preparation and shelter. Blizzards and sandstorms are different in appearance, but both can shut down entire regions. A blizzard blankets landscapes in freezing winds and zero visibility, trapping people indoors and making travel deadly. Meanwhile, extreme sandstorms rise like towering walls of dust, darkening the sky and turning day into night. They cause respiratory problems, damage crops, and bury infrastructure under layers of sand. These storms show how powerful the atmosphere can be, whether filled with ice or dust. Preparation, shelter planning, and early warnings are crucial for survival. A solar superstorm is not a weather event on Earth, but in space. When the sun releases a massive burst of charged particles, these waves race toward Earth and collide with our magnetic field. Though invisible to the eye, the effects can be dramatic. Satellite failures, GPS disruption, radio blackouts, and widespread power outages. The last major event, the Carrington event of 1859, lit up nighttime skies around the world. If a similar storm hits today, our technology-dependent society could face global interruptions. Monitoring the sun is key to protecting our digital world. Sinkholes appear suddenly, but form slowly underground. Water dissolves rock beneath the surface, especially limestone, creating cavities that grow over time. When the ground above can no longer support its own weight, it collapses, forming a hole that can be a few meters wide or large enough to swallow buildings. Human activities like drilling, mining, leaking pipes, or draining groundwater can accelerate the process. Understanding the geology of an area helps identify risk zones. The best defense is awareness, monitoring, and quick action when warning signs appear. Dust storms and sandstorms form when powerful winds lift loose soil or sand into the air, creating clouds that can stretch for kilometers. They can reduce visibility to almost zero, damage lungs, shut down airports, and bury roads and crops. Dust storms usually involve finer particles that travel farther, while sandstorms carry heavier grains that stay closer to the ground but strike with more force. These storms often follow droughts, land degradation, or extreme heat. Preventing them starts with soil protection, vegetation cover, and sustainable land use.
Ice storms occur when freezing rain coats everything it touches with a thick layer of ice. While beautiful, they are incredibly destructive. Trees snap, power lines collapse, and roads become dangerously slick. Even a thin layer of ice adds enormous weight, enough to black out entire regions. Ice storms also bring extreme cold, making power outages life-threatening. Weather forecasting, emergency kits, and infrastructure upgrades help reduce the risks. A blizzard brings heavy snow and fierce winds, but a whiteout is what makes it truly deadly. In a whiteout, snow and wind eliminate all contrast. Sky, ground, and horizon blend together, making it impossible to navigate. Travelers can become disoriented in seconds. Blizzards can shut down entire cities, freeze power lines, and trap people in vehicles or homes. Survival depends on staying sheltered, avoiding travel, and monitoring weather alerts. These storms show how quickly winter can overpower even the strongest communities.
An epidemic occurs when a disease spreads rapidly within a region. A pandemic happens when that spread becomes global. Scientists track viruses using genetic sequencing, modeling, and surveillance systems. Transmission can occur through air, contact, water, or vectors like mosquitoes. Vaccination, hygiene, early detection, and communication are essential tools in controlling outbreaks. Modern pandemics remind us how interconnected our world is and how scientific cooperation, research, and preparedness can save millions of lives.
Meteors enter Earth's atmosphere every day, but most burn up harmlessly. However, large asteroids or meteoroids can reach the surface and cause devastating impact events. The energy released can equal thousands of nuclear bombs, generating shock waves, fires, and global climate effects. Scientists track near-Earth objects using telescopes and radar to identify potential threats. While major impacts are rare, studying them helps us develop strategies like deflection missions to protect our planet from cosmic hazards.
Our planet is powerful, beautiful, and unpredictable. Disasters are inevitable, but we can protect ourselves, our communities, and our Earth. In the next hour, we explore how science, technology, and human action can prevent, prepare for, and respond to natural disasters.
Earthquake preparedness. Earthquakes strike without warning, but preparation saves lives. Seismic building codes, early warning systems, and community drills can reduce destruction dramatically.
Unstable slopes can collapse, but soil management, drainage systems, and slope reinforcement can prevent landslides. Wildfires can be devastating, but controlled burns, vegetation management, and early detection save lives and ecosystems. Hurricanes can devastate cities, but accurate forecasting, building reinforcement, and evacuation planning reduce casualties.
Extreme heat threatens health. Green spaces, cooling centers, urban planning, and renewable energy help communities adapt. Viruses spread quickly, but vaccines, early detection, hygiene, and global cooperation reduce impact. Space rocks are rare but can be deadly. Satellite monitoring and early deflection strategies give humanity a chance to respond. Preparedness starts with knowledge and action. Communities, schools, and families can implement emergency plans, kits, and drills.
For centuries, disasters struck without warning. Storms appeared out of nowhere. Earthquakes shattered cities in seconds, and tsunamis rose like walls of water with no sign. But today, humanity stands in a new era, an era where technology gives us the power to see danger before it strikes. From space, satellites orbit the planet, scanning every movement of clouds, ocean temperatures, and atmospheric pressure. These high-resolution eyes in the sky detect the birth of hurricanes days before they form and track their paths with incredible accuracy. Deep in the ocean, thousands of tsunami detection buoys sit quietly on the seafloor, listening to the smallest pressure changes. When they sense an abnormal wave pattern, they instantly transmit alerts across the world, giving coastlines precious minutes that can mean the difference between life and death. In earthquake zones, seismographs monitor the vibrations beneath our feet. In places like Japan, these sensors can send warnings seconds before the shaking reaches major cities, allowing bullet trains to stop and elevators to lock open. Countries now share disaster data through global systems, including the World Meteorological Organization, creating a network that protects not just nations, but humanity as a whole. This is the future of resilience, a world where technology becomes our shield, where information saves lives, and where early warning is our most powerful defense. Long before humans built cities, nature had already crafted perfect defenses against storms, floods, and rising seas. Today, scientists are rediscovering that Earth itself holds the solutions to many of the disasters we face. Along coastlines, mangrove forests stand like natural shields. Their tangled roots trap sediment, slow down waves, and reduce storm surges by up to 60%. During strong typhoons, communities with mangroves suffer far less damage than areas that cleared them. Coral reefs play an equally powerful role. These underwater walls break the energy of incoming waves, acting like natural breakwaters. Without reefs, coastal cities would face much stronger storms and erosion. Forests help control rainfall and prevent landslides by absorbing water through thousands of interconnected roots. Trees create their own microclimates, cooling the air, stabilizing slopes, and keeping the soil in place. Wetlands and floodplains store excess water when rivers overflow, acting as natural sponges during heavy storms. Instead of concrete walls, restoring wetlands is now one of the most effective ways to reduce flooding. Nature protects us if we protect nature. Our greatest defense against disasters may not be walls, dams, or barriers, but the living systems that have evolved over millions of years. A new generation of innovators is reshaping how we protect our planet, using technology not as an enemy of nature, but as its partner. Solar and wind power are transforming cities, reducing pollution and slowing the warming of our atmosphere. Massive fields of wind turbines and solar farms generate clean energy that helps reduce the severity of climate-driven disasters. In modern cities, engineers are designing smart homes that can sense earthquakes, automatically shut off gas lines, and reinforce their foundations in real time. Skyscrapers sway safely during strong winds thanks to intelligent stabilizers hidden within their core. Artificial intelligence is leading the way in climate prediction. Supercomputers analyze millions of data points, from ocean heat patterns to atmospheric pressure, to forecast storms with extraordinary precision. Even basic innovation saves lives. Flood-resistant roads, elevated homes, water-absorbent pavements, self-healing concrete, and vertical forests that clean polluted air. This is the era of green technology, the fusion of human creativity and natural systems working together to create a safer world.
When disaster strikes, the first responders are not always firefighters or rescue units. It's the community. Prepared communities survive more, respond faster, and recover sooner. Across the world, families, schools, and barangays practice drills that turn fear into readiness. Earthquake drills teach children to drop, cover, and hold. Fire drills show families how to escape safely within seconds. Flood drills map out escape routes, evacuation centers, and emergency communication plans. Emergency kits, simple items like flashlights, medicines, radios, water, and food, become life-saving tools in the first 72 hours after a disaster. During real emergencies, communities with trained volunteers save countless lives. They guide neighbors, help the elderly, rescue pets, and coordinate evacuations long before official responders arrive. Preparedness is not about removing fear. It's about giving people the power to act.
Disaster preparedness begins at home. Every person, every family can make decisions today that will save lives tomorrow. Start by reinforcing your home. Secure heavy shelves. Anchor appliances. Elevate electrical outlets in flood-prone areas. And make sure your roof is properly fastened. These simple actions can prevent injuries and reduce damage. Prepare a 72-hour emergency kit with everything you need to survive independently. Water, food, flashlights, batteries, medicines, documents, and communication tools. Create a family plan. Where will you meet if phones stop working? Who grabs the pets? Who checks on grandparents? Planning costs nothing but saves everything. Learn survival basics. How to shut off gas lines, perform CPR, read weather alerts, and recognize early danger signs. Preparedness is not paranoia, it is peace of mind. A ready home is a safe home, and a safe home is the foundation of a resilient community.
When disaster strikes, the true test is not only physical, it is psychological. Panic spreads fast, fear clouds judgment, and stress makes decision-making difficult. But understanding human behavior during crises can save lives. People who remain calm think more clearly. Communities that stay connected respond more effectively. Even simple reassurance, one voice saying, "We will get through this," can prevent chaos. After disasters, emotional recovery is just as important as repairing homes. Trauma, anxiety, and grief can last long after the debris is cleared. Support groups, counseling, and community unity help people heal. In times of crisis, humanity is at its best. We share food, give shelter, rescue strangers, and rebuild together. Disasters may break structures, but they reveal the strength of the human spirit.
Disasters are not only measured in lives lost, they are measured in the cost of rebuilding. Every year, the world spends hundreds of billions of dollars repairing damage caused by storms, floods, quakes, and wildfires. Homes destroyed, cities submerged, businesses closed, families displaced. But what if the world invested even a fraction of that money in preparedness? Studies show that every dollar spent on disaster prevention saves up to $7 in recovery costs. Choosing not to act is the most expensive decision of all. Climate change intensifies storms, melts ice caps, raises sea levels, and fuels wildfires. The longer we delay action, the harder and costlier the recovery becomes. Prevention is not just an environmental issue. It is an economic strategy, a humanitarian investment, and a moral responsibility. The earth is alive. Mountains shift. Oceans roar. Storms rage. Fires burn. Ice falls. Meteors strike. Disasters test humanity, challenge our survival, and remind us of the fragile balance we live in. Tonight,
we explore 15 of the deadliest disasters ever recorded. On December 26, 2004, one of the deadliest natural disasters in recorded history struck without warning. A massive undersea megathrust earthquake off the coast of Sumatra triggered a series of colossal tsunamis that raced across the Indian Ocean at jet plane speeds. Entire coastlines, from Indonesia, Sri Lanka, India to Thailand, were overwhelmed within minutes. Waves reaching up to 30 meters high swallowed villages, resorts, and cities, destroying everything in their path. More than 230,000 lives were lost and millions were displaced, leaving behind a trail of unimaginable devastation. Yet, amid the chaos, stories of survival, global humanitarian response, and unprecedented unity emerged. The 2004 Indian Ocean tsunami became a wake-up call for the world, pushing nations to improve early warning systems and coastal preparedness. Today, its memory remains a powerful reminder of nature's force and the importance of readiness, resilience, and compassion. The 2011 Tohoku earthquake and tsunami, which occurred on March 11, 2011, was a catastrophic event with far-reaching consequences for Japan and the world. It is often referred to as the Great East Japan Earthquake. The earthquake and tsunami. Magnitude. The earthquake had a magnitude of 9.0 to 9.1 MW, making it the most powerful earthquake ever recorded in Japan and the fourth most powerful in the world since modern record-keeping began in 1900. Epicenter. The epicenter was located approximately 72 kilometers, 45 miles, east of the Yoshika Peninsula of the Tohoku region, at a relatively shallow depth of about 24 to 32 kilometers below the sea floor. Tsunami. The powerful undersea megathrust earthquake triggered massive tsunami waves that reached heights of up to 40.5 meters, 133 feet, in Miyako, Iwate Prefecture. The waves traveled up to 10 kilometers, 6 miles inland in the Sendai area, devastating coastal communities. Casualties. The combined impact of the earthquake and tsunami resulted in a confirmed death toll of over 19,700 people, with more than 2,500 still listed as missing. The vast majority of deaths were caused by drowning. Fukushima Daiichi nuclear disaster. The tsunami waves, which were far higher than the plant's seawalls was designed for, flooded the Fukushima Daiichi nuclear power plant, leading to a severe nuclear accident. Station blackout. The tsunami flooded the plant's basement, disabling the emergency diesel generators that were providing backup power to the cooling systems after the main power grid failed due to the earthquake. This resulted in a complete loss of power, known as a station blackout. Cooling failure and meltdown. Without power, the cooling systems for reactors 1, 2, and 3 failed. The reactor cores overheated, leading to a partial meltdown of the nuclear fuel. Hydrogen explosions. The intense heat caused the chemical reaction that produced hydrogen gas. The gas built up within the reactor buildings and caused explosions in units 1, 3, and 4, severely damaging the structures and releasing radioactive materials into the atmosphere. Radioactive release. The accident resulted in the release of significant amounts of radioactive materials, primarily iodine-131 and cesium-137, into the air and ocean. This led to the evacuation of over 160,000 residents from a 20-kilometer, later expanded, exclusion zone around the plant. The accident was classified as a Level 7 event on the International Nuclear and Radiological Event Scale, IONS, the highest level, matching the Chernobyl disaster. Consequences and aftermath. Economic impact. The disaster is estimated to be the costliest natural disaster in history, with direct economic losses estimated at around $220 to $360 billion. Displacement. The earthquake, tsunami, and nuclear disaster displaced close to 500,000 people. Years later, tens of thousands remained unable to return to their homes, particularly in the areas around the Fukushima plant. Environmental impact. The release of radioactive materials contaminated land and sea, leading to long-term environmental concerns and restrictions on agriculture and fishing in affected areas. The cleanup and decommissioning of the Fukushima plant is an ongoing process expected to take decades. Policy changes. The disaster led to a complete overhaul of Japan's nuclear regulatory framework and prompted a global reevaluation of nuclear safety standards, particularly regarding the protection of power plants against extreme natural hazards.
In late 2019, Australia faced one of the most devastating environmental disasters in modern history. What began as scattered fires quickly exploded into a nationwide catastrophe, fueled by extreme heat, prolonged drought, and fierce winds. Entire forests turned into blazing infernos, creating skies so red and thick with smoke they could be seen from space. Over 24 million hectares of land burned, an area nearly the size of the United Kingdom. Homes vanished, towns were engulfed, and families were forced to flee through walls of flame. But perhaps the greatest tragedy was ecological. Nearly 3 billion animals were killed or displaced, pushing some species to the brink of extinction. Yet, even through the destruction, humanity rose. Firefighters battled day and night. Volunteers sheltered injured wildlife. Communities came together in incredible acts of courage and compassion. The Australia bushfires of 2019-2020 remain a painful reminder of our planet's vulnerability and a powerful call to protect the world we still have.
The Australia's Black Summer bushfires, 2019 to 2020, were an unprecedented and catastrophic fire season that significantly impacted the country. Here is a summary of the causes, timeline, and impact. Overview and causes. Period. The fires, which began in June 2019, intensified dramatically from September 2019 to March 2020, with the most severe activity between December 2019 and January 2020. Key drivers. The intensity and scale of the fires were primarily driven by extreme weather conditions. Record heat and drought. 2019 was Australia's hottest and driest year on record, following years of protracted drought in the southeast, creating tinder-dry fuel loads. Climate change. There is a confirmed trend of worsening fire weather and larger, more intense wildfires linked to climate change. Ignition. The fires were started by various factors, including dry lightning strikes. Timeline highlights. Early start, June 2019 to August 2019. Early fires began in Queensland and progressed southward. Intensification, September 2019 to November 2019. Fires heavily impacted regions in New South Wales and Queensland, with the fire season beginning 2 months early in some NSW areas. Peak catastrophe, December 2019 to January 2020. This period saw the most devastating, widespread, and uncontrollable megafires, especially across New South Wales and Victoria. A state of disaster was declared in Victoria. Containment, February to March 2020. Heavy rainfall in mid-February helped firefighters contain all fires in New South Wales, with all remaining fires contained or extinguished by early March 2020. Impact and statistics. Category: impact or statistic, area burned. Over 19 to 24 million hectares, around 47 to 59 million acres of land burned across the country, mostly in New South Wales and Victoria. Human loss: 33 people lost their lives directly in the fires, with hundreds more estimated deaths due to smoke inhalation and related health issues. Property loss. Over 3,000 homes were destroyed, along with thousands of other buildings. Wildlife and environment. Nearly 3 billion animals, mammals, reptiles, birds, and frogs were estimated to have been killed or displaced. The fires devastated ecosystems, including ancient Gondwana rainforests. Public health. Widespread smoke haze and air pollution affected major cities, with Canberra recording the worst air quality index of any major city in the world at the peak. The 2005 storm Hurricane Katrina was one of the deadliest and most destructive hurricanes in U.S. history, leaving a catastrophic and lasting impact, particularly on the Gulf Coast. Overview and path. Formation and intensity. Katrina formed as a tropical depression over the Bahamas on August 23, 2005. It rapidly intensified in the unusually warm waters of the Gulf of Mexico, reaching a peak of Category 5 intensity with sustained winds of 175 miles per hour. 3. Landfalls. August 25 made first landfall in Florida as a Category 1 storm. 4. August 29 made major landfall near Buras, Louisiana as a powerful Category hurricane. Catastrophic impact. The devastation was largely due to the storm surge and the subsequent failure of New Orleans' levee system. 5. Category, impact and statistics. Fatalities. An estimated 1,833 people died, mainly in Louisiana and Mississippi, making it one of the deadliest hurricanes on record. Economic cost. Estimated total damages were around $125 to $161 billion, making it the costliest hurricane in U.S. history. New Orleans flooding. The storm surge overwhelmed and breached dozens of federal flood protection structures, flooding approximately 80% of New Orleans. In some areas, floodwaters reached depths of 20 feet, 6 meters. Displacement. Hundreds of thousands of residents were displaced from their homes, leading to one of the largest internal displacements in U.S. history. Infrastructure. The storm severely damaged or destroyed more than 200,000 homes. Major highways were disrupted, and the damage to oil and gas infrastructure in the Gulf of Mexico caused nationwide fuel price spikes. Environmental. The storm caused at least 10 major oil spills and contaminated the floodwaters with sewage, chemicals, and industrial waste. Societal and aftermath. Levee failure. While the hurricane struck New Orleans as a Category 3, the subsequent flooding was primarily caused by the failures of the city's federally built and maintained floodwalls and levees along the canals. 6. Response. The response to the disaster by all levels of government, local, state, and federal, was widely criticized as slow, disorganized, and inadequate, particularly concerning the aid provided to the city's poorest and most vulnerable residents. 7. Long-term effects. The hurricane had profound long-term social and demographic consequences. Many residents, especially low-income and African-American families, were unable to return, permanently altering the city's population and social fabric.
The powerful magnitude 2, $7.8 earthquake and its aftershocks caused catastrophic damage, leading to the scenes you mentioned, 3 temples collapsing. Many centuries-old historic temples and monuments, particularly in the UNESCO World Heritage sites of the Kathmandu Valley, like Kathmandu, Patan, and Bhaktapur Durbar Squares and the Dharahara Tower, were destroyed or severely damaged. 4 dust clouds, the collapse of numerous brick and masonry buildings and temples, would have generated massive clouds of dust in the affected cities, crowds fleeing. The intense shaking and fear of further aftershocks caused residents and tourists to flee buildings and seek refuge in open spaces like streets, parks, and fields. 5. The earthquake resulted in the tragic loss of approximately 9,000 lives and left hundreds of thousands homeless. 6. The images of collapsing, historical structures and panicked crowds were widely broadcast globally at the time.
The 2020 Beirut explosion was a catastrophic event that occurred on August 4, 2020 at the port of Beirut in Lebanon. Here are the key details about the disaster. Cause and immediate impact. Cause. The explosion was caused by the detonation of approximately 2,750 tons of ammonium nitrate, a chemical compound used in fertilizers and explosives that had been improperly and unsafely stored in a port warehouse, Warehouse 12, for 6 years, despite repeated warnings from port officials. Trigger. The ammonium nitrate detonated after a fire broke out in a nearby warehouse which purportedly stored fireworks and other materials. Scale. The blast was one of the largest non-nuclear explosions in history, generating a seismic event measuring 3.3 in magnitude. Casualties. Fatalities. Over 218 people were killed. Injuries. Around 7,000 people were injured. Displacement. Approximately 300,000 people were left homeless. Damage. Property damage was estimated at over $15 billion, devastating the port and large areas of the capital city. Long-term and political impact. Political unrest. The explosion fueled public anger over government corruption and negligence, leading to large-scale protests and the resignation of Prime Minister Hassan Diab and his cabinet shortly after the blast. Economic crisis. The destruction of the port, a vital hub for trade, exacerbated Lebanon's existing economic and financial crises, contributing to food shortages due to the destruction of the grain silos and business closures. Healthcare. Several major hospitals were severely damaged, severely straining the healthcare system, which was already grappling with the COVID-19 pandemic. Mental health. The disaster caused widespread psychological trauma with post-traumatic stress disorder, anxiety, and depression noted as significant psychological impacts among citizens. Investigation and search for justice. Investigation status. The judicial investigation into the explosion has been repeatedly obstructed and suspended by political interference and legal challenges brought by high-ranking officials who have been summoned for questioning. Lack of accountability. As of late 2025, according to recent reports, no government or port official has been convicted or held to account despite the disaster being attributed to negligence and systemic corruption. Victims' families of the victims and survivors continue to demand an independent, impartial, and unobstructed investigation to achieve justice for those who died. The powerful magnitude 7.8 earthquake and its aftershocks caused catastrophic damage, leading to the scenes you mentioned. Temples collapsing, many centuries-old historic temples and monuments, particularly in the UNESCO World Heritage Sites of the Kathmandu Valley, like Kathmandu, Patan, and Bhaktapur Durbar squares, and the Darahara Tower, were destroyed or severely damaged. Dust clouds. The collapse of numerous brick and masonry buildings and temples would have generated massive clouds of dust in the affected cities. Crowds fleeing. The intense shaking and fear of further aftershocks caused residents and tourists to flee buildings and seek refuge in open spaces like streets, parks, and fields. The earthquake resulted in the tragic loss of approximately 9,000 lives and left hundreds of thousands homeless. The images of collapsing historical structures and panicked crowds were widely broadcast globally at the time.
Sinkholes are sudden collapses of the ground that can swallow roads, buildings, and even whole neighborhoods. They form when underground water dissolves soluble rock, like limestone, or when human activities, such as mining, drilling, or leaking pipes, destabilize the subsurface. Human impacts. Property loss homes and commercial buildings can be destroyed overnight, leaving families homeless and businesses shuttered. Dust and sandstorms can have a surprisingly wide range of impacts on people. Respiratory problems, fine particles irritate the lungs, aggravating asthma, bronchitis, and other chronic conditions. In severe storms, even healthy adults can experience coughing, shortness of breath, or chest pain. Eye irritation, the gritty dust can cause redness, tearing, and if it gets into the eyes, temporary vision loss or corneal abrasions. Cardiovascular stress. The biggest ice storm disaster on record is the North American ice storm of 1998, often called the Great Ice Storm of 1998. Between 4 and 10, January 1998, a band from eastern Ontario through southern Quebec and into northern New York and Maine was hammered by up to 100 millimeters, 4 in, of freezing rain and ice pellets. The storm left 35 people dead, displaced about 600,000 residents, knocked out power for nearly 1.4 million customers, and caused $5.7 billion in economic losses. The Great Blizzard of 1888, the Great White Hurricane, is widely regarded as the biggest blizzard that turned the landscape into a whiteout. From March 11 to 14, 1888, a massive nor'easter slammed the northeastern United States, dumping 40 to 58 inches of snow and driving winds up to 85 miles per hour. The storm created virtual whiteout conditions. Visibility dropped to just a few feet, streets vanished, and residents described waking up to a white wall that made it impossible to see even a few meters ahead. The deadliest landslide on record is the Haiyuan landslides that followed the massive 1920 Gansu, China earthquake. Estimates put the death toll at about 200,000 people, making it the biggest landslide disaster in history. For context, other catastrophic events include the 1970 Yungay landslide in Peru, 22,000 to 25,000 deaths, and the 1999 Vargas tragedy in Venezuela, 10,000 to 30,000 deaths, but none match the scale of loss seen at Haiyuan. The deadliest pandemic in human history is the Black Death, 1346 to 1353. It swept through Europe, Asia, and North Africa, wiping out an estimated 200 million people, roughly a third of the world's population at the time. For perspective, the next biggest killers were the 1918 Spanish flu, 20 to 50 million deaths, and the HIV/AIDS pandemic, about 36 million deaths to date. So when people talk about the worst pandemic disaster, the Black Death is the one that tops the list. The biggest meteor disaster we know of is the Chicxulub impact about 66 million years ago, a roughly 10 km wide asteroid that hit what's now the Yucatan Peninsula. It released energy equivalent to billions of atomic bombs, triggering the mass extinction that wiped out the dinosaurs. Other notable events: Tunguska 1908, Russia, about 50 m asteroid, flattened 2,000 km2 of forest. Chelyabinsk 2013, Russia, 20 m meteor, injured over 1,500 people. This video was never created to frighten anyone or to relive the disasters of the past. It was made to remind us that natural disasters are a part of our world. And while we cannot stop all of them, we can always choose how we prepare, how we respond, and how we protect one another. Disasters can happen anytime, but fear is not the answer. Preparedness is. Knowing what to do, where to go, and how to stay safe turns uncertainty into confidence. And above all, this documentary is a reminder that our greatest protection starts with how we care for our planet. Every tree we plant, every coastline we protect, every piece of plastic we refuse, every choice we make, big or small, helps prevent future catastrophes and keeps our world safer for the next generation. So let us not live in fear of disasters. Let us live with awareness, responsibility, and hope. Together we can prepare. Together we can protect. Together we can build a safer place.